first lecture of the hydraulic engineering to introduce this course and review the hydraulics subjects. The first topic is the scope of the hydraulic engineering. So the broad picture of the hydraulic engineering is the application of the fluid mechanics and data science and engineering discipline into the design of the structure and development of the project and of project and the system involving water resource. Okay. First, we have to consider the role of the hydrologic engineer. For the hydrologic engineer, they have to give us the design parameter from the analysis of rainfall runoff data. For example, what is the annual flood and what is the runoff, and for the peak flow they give the design flood with the complete structure must be passed without this danger. So in terms of the drought, they have to estimate the volume of water available to meet the demand of the project. Once we know the peak flow, we can for the hydraulic engineer, they can develop the conceptual design for to drain the peak flow, such as to design the spillway, the outlet of the dam, and convert of the highway to drain this peak flow. And in terms of the water supply, hydraulic engineering can design the canals, the pump or the pipeline to transmit or to send the water from water resource to user. And the other application is for example, cooling water facility for thermal power plant. Okay, so involving the detailed design of the hydraulic structure. So that is the scope of the hydraulic engineering. Trend in the future is we have to involve in like the thermal power plant to design the cooling water system. Have to involve in the hydroelectric development, and there is the conflict in water development from upstream to downstream. So that the people along the river or the canal, if we divert a lot of water for irrigation and for upstream, and we leave too little water downstream, so that is the conflict. The people at the downstream to do fishing and the other aquatic life. Okay. The next topic is reviewing of the concept of the fluid flow. Just to review from the hydraulic course. The first topic is fluid static. Okay, if we write in terms of the P equal to gamma H something. Okay, in this case, because of the depth of the flow is decreased, negative, because it's negative, so we got the minus sign for the minus gamma. Okay, so for the force is equal to pressure time area. Okay, so we can find the force, and for the next in this picture show the inclined submerged surface. Okay, in this case we can see what is this is a force acting on the inclined submerged surface. Okay, Fr, and Fr acting on the center pressure Cp. Yes, center pressure, and on this plate there is a central C is a centroid of the area. Okay, and in this case we have parameter, for example the Hc, okay, the depth of the centroid, okay, and the Yc is the length along the y-axis of the centroid, and for the location of the force we have what is that? This is yr, okay, and xr. this XR is location of the center pressure. So for the XR we can estimate on based on this equation, okay, moment of inertia divided by YCA plus XC to get the center pressure. Next topic is the buoyancy force, okay, for flotation and stability. So the main concept is the main equation is buoyancy force equal to gamma times the repressed volume, the specific weight of water times volume of depressed water. Okay. Next we learn from the hydraulic course is Bernoulli equation. Okay. This equation is constant. The pressure plus the velocity pressure and the static pressure. So we can, another one we can write in terms of the depth, pressure depth, P divided gamma plus the velocity head plus static head is a constant. Okay, and we learn how to use this Bernoulli equation. This is constant along the streamline. And the next we learn about the energy line and hydraulic current line. Okay, energy line is like the just only the second two term of the Bernoulli pressure term plus the static term, and if we add the velocity here, so we got the energy line. Okay. And the next topic we learn how to use the Reynolds transport theorems. Okay. From this equation, the first B, capital B is a mass, and we divided by per mass we got B, small b, and this term we can explain that the time rate of change of the mass of the coincidence system is equal to the time rate of change of mass inside the control volume plus the net rate of flow of mass through the control surface. And that is the explanation of the Reynolds transport theorem. And next we the keyword is control volume. Okay, so this is control volume for the green line, that is control volume. Okay, we use control volume is like the boundary of the free body diagram, and to think about and apply the Reynolds transport theorem for this boundary. So we and after identify what happened to this control volume inside the control volume and on the surface of control volume. Okay, to make the free body diagram of the problems. And then the next application of the control volume is if B is angular momentum. So in this term we can apply for the rotation of water sprinkler to explain the change of velocity in the angular velocity. Okay, and this one we can see the control volume is in this is one control volume. And the next topic is we learn about this dimensional analysis. Okay, in this case, okay, the chain of, for example, the chain of pressure. The chain of pressure is a function of the diameter, density, and the viscosity. So we can develop the equation from using the Birmingham pi theorem. Okay. The next, the modeling and similarly test, so it means the connection between the prototype and model. Okay, we use the pi term to explain if the prototype and behavior of the prototype and model is the same. It means this term, this parameter should be the same. Okay, it means pi term for the model is equal to from the prototype. For the main parameter that we use is a foot number. Okay, if the behavior of the model and prototype is the same. The foot number is the measures parameter. Okay, and the other thing is the viscous flow in the pipe. Okay, we develop the equation for the laminar flow, and we have another equation for turbulent flow. It's like Q is equal to but this is a head loss in another. Okay, this head loss is Darcy Weisbach equation. This equation we apply this equation for the turbulent flow. Okay. And we learn the basic for the turbo machine, for the basic angular momentum consideration, and we can apply the knowledge to design the centrifugal pump and do the turbines. Okay, and the next topic that we're going to extend from this knowledge is the open channel flow. Okay, so we can classify into uniform flow, gradually varying flow, and rapidly varying flow. Okay, based on this flow profile. And one equation that we learn is we call the specific equation. Okay, to explain the flow in open channel flow. Okay. We're going to do further from this basic equation, and the topic is the uniform depth of the channel. Okay, based on the this control volume of the uniform flow of an open channel flow, we can use the two equations, CSC equation and Manning equation. Okay, and then we can, and the next talk, I think we didn't, for the hydraulic, we're going to discuss about the base hydraulic section. Okay, and explain more the gradually varying flow and rapidly varying flow and the hydraulic jumps. Okay, we learn from hydraulic jump a little bit from the hydraulics, and we go further to extend knowledge of hydraulic jump for the design of the spinway. Okay, and about the flow measure, the flow rate in operational flow, we use the flow meter, the one instrument we call the sharp Cresvier, and we also do practice in the lab. Okay, and this is flow for pipe flow meter. We use the orifice nozzle and venturi and to measure the flow. Okay, okay, you learn from review this this knowledge, and we can, in the class we will discuss these three questions. Okay, about the example of the hydraulic project in Kolat and example of hydraulic project in the northeast of Thailand, and what is the main resource and component of HUT water supply system. You can find the information by yourself and discuss in the class. Okay.